Hello everyone, my name is Khalid Lahna. I am practice leader in self-service and advanced analytics at BGFi Consulting in Paris. And this morning I will explain the concept and the role of the citizen data scientist. So first of all, I would like to apologize for my English. If you don't understand me, please do not hesitate to send me a message and I will try to repeat. So here, in this webinar, I will first introduce the business user need, especially in terms of autonomy and analytic capabilities. Second, I will then give you a presentation of the concept of citizen data science. Then, I will explain the requirement to be a citizen data scientist. And finally, I will introduce a use case around citizen data science. So now the business user needs. In IT domain, business users are often seen as customers. There are people who express a need, for example, having access to a database, automating the loading of Excel files, etc. And they have difficulty with the possibility of choosing non-recommended IT tools. So this can create a lot of frustration because they need in their business to be as responsive as possible, and they do not want to waste time constantly interacting with IT for any evolution. For example, I have seen cases where it is necessary to wait several days just to change the loading of that file or to add a new filling table. So usually you have to create a ticket, then you will need to be the ticket to be approved by the IT, then to test if the enhancement is correct, etc., etc. So that's why business users, they want to have the opportunity to do their own analysis. We don't necessarily mastering SQL code or computer code to gain agility. So of course, this analysis could then be checked with technical user or even to the IT if they are correct, for example. So here in this slide, you can see the whole chain that will allow a user to analyze his data. So here it goes from data preparation to decision-making process. Here, the first step, prepare data, will involve all the tools around the preparation of data, such as ETL. ETL means extract, transform, and load, such as Microsoft SSIS, IBM Data Stage, Talent, etc., etc. So normally this steps is the one that requires the most time and will often depend on IT because it mobilizes technical skills, because you need to know how to write SQL code or to write script, these kind of things. So here, the second and third steps then allow this result to be analyzed. So this is the part that gives users the most autonomy thanks to data visualization tools like Tableau software, Microsoft Power BI, ClickSense, IBM Cognos, for etc., etc. So, however, with this concept, we are still in traditional business intelligence. So in this slide, to summarize, before we had a clear division between business and IT. Both often had communication problems, particularly on the choice of IT tools and the analysis to be performed. These problems have consequences has to give very little agility to business. Like I said, when you need to do an enhancement, you must wait several days, for example. So now, with the arrival of self-service BI tools, like I said, Tableau, Power BI, ClickSense, it is now possible to just provide access to data and let users make their own analysis and create their own KPIs. So it is thanks to these tools that it is now possible to have a data-driven company that is going to allow all employees, like marketing, finance, accountability, even IT, to themselves analyze their own data to exploit the relevant information. So after, there's complex analysis, which often required data scientists, become accessible to business users who have the skills to understand and process the data. We call it a citizen data scientist. So now I will explain the concept of citizen data science. So the concept of citizen data scientist was introduced by Gartner in 2016 and is the assumption that the data scientist is one of the most demanded professions in IT, according to Indeed, but it is difficult to find him use cases that exploit his competency. So we can say that it's a little bit paradoxal. So in addition, business intelligence tools are increasingly integrating advanced analysis models that do not require development. So the evolution of these tools therefore allow the business users to make their own analysis, to leave data scientists' works on the verification and improvement of predictive models. So that's why Gartner said that citizen data science augments data discovery and simplifies data science. So, as I said before, the citizen data scientist is above all a business user who knows his data. It's very important. These business users are used to using self-service BI tools to explore his data and wants to start predictive analysis. For example, we can have a user who works in a banking company and wants from the transaction history of his customers to anticipate the risks of fraud based on indicators such as the frequency of payments, the location of these payments, the average amount, etc., etc. So the citizen data scientists therefore use pre-designed models that data scientists use to develop themselves in Python or R, for example. The citizen data scientist must also have technical skills. He knows where to look for his data, but also needs to know which predictive model or algorithm to use for his analysis. He therefore has a curiosity for data and use advanced analysis tools such as Alteryx or DataIQ. So now I will show you the requirements for advanced analytics. So the prerequisites to do citizen data scientist is to master 4 aspects. First, you have to be able to easily prepare data with a minimum of time. This preparation must be replicable and automated for further analysis. So is data preparation. It is also necessary to be able to connect to many different data sources, like SQL database, CSV file, API, etc., and to support a large volume of data. When I say a large volume of data, it's a million or 100 million of data. The third prerequisite is to be able to integrate your analysis with other existing systems in order to easily share it. For example, you can create a visualization with Tableau or Power BI, and then you can share it easily with a web URL to your own website or just to send it to your colleagues. And here, finally, the tool must have advanced data analysis features. For example, the ability to test machine learning model. So here in this slide, you have tools that we have placed in different categories. Of course, this ranking is not exhaustive, and the tools can be in several categories at once. For example, in the category of data mining and self-service analytics, I put the 3 main tools that are Tableau, Power BI, and ClickSense, but these tools also have advanced analysis features. That's why here we have data mining, Tableau, Power BI, Click, advanced analytics, Alteryx, DataIQ, and machine learning, data robot, RapidMiner. Of course, there is other. So now I will show you a use case about the citizen data scientist. In this use case, I, a data analyst, I work in a company which offers ready-made meals. And first, as a data analyst, I will try to get a detailed description of my recipes. And after, as a citizen data scientist, I will try to use algorithms or predictive model to recommend new recipes to my customers. So for this demo, I will use two tools: Alteryx Designer for the preparation and advanced analytics, and Tableau Desktop for visualization. So Alteryx is a tool that can be placed, as I said, Alteryx is a tool that can be placed in both self-service analytics and data science. Here in my example, I have a join between two files, receipts and user. They are CSV files. First, the goal is just to make a join between these two files in order to prepare my data. So for this, I use the tool join. I can have it here, the join, and I use the ID for receipt and receipt ID for user, and receipt ID for receipt. So as you can see, I use tools that make it easy to join files without watching code. So here with receipt and user, I did my join and I have the result here. More than 1 million records. So now, as a user who knows this data, I know that the nutrition column right here, this column. So I know that the nutrition column is divided into 7 columns. And I know that the first value corresponds to here to the calorie index. Second is the fat level, after the carbohydrate, etc., etc. So now I will need to prepare my data to use this information. So that's why I will use this, a regular expression, regex, to clean my data by removing the brackets. So I will put this regular expression, and you can see the result before I have the bracket in nutrition, and after I removed the brackets. So after that, I want to pass my column nutrition in 7 columns. So now Alteryx offers me these tools. If I go to pass, I have text to column. And here I just have to select nutrition column, and I will split this column in 7. So here you can see before, I have this column nutrition and nothing after. And if I go there, now my column is passed in 7. So now I just have to rename my data to give them the correct name. That's why I will use this to select. And here I have nutrition 1, 2, 3, etc. Now I can put the right name: calorie, fat, sugar, sodium, protein, etc., etc. So after, for my analysis, I will extract the submission year and the review year. So it's easy. I just have to use a function in Alteryx to extract the date time year to submit, and the date time year in date. And here you can see the data preview here and here. So of course this work could have been done by a Python data scientist, but that's not the most interesting part. You can see it's a very easy preparation. So the advantage of this solution is that I have the ability to easily modify my workflow, which gives me agility in analysis. So now if I want to add a column, I just have to, if I want to add another file, I can do it, and I can do my own join. I can add or remove column. I can create my own calculation, etc., etc. So after that, if I go this here, I will now do a correlation calculation using the Pearson correlation. Yes. So the Pearson correlation is an algorithm that will compare several values and will determine if there is a dependency between them. If I have 1, I have a perfect correlation. If I have 0, I do not have a correlation. So this may be interesting, for example, if there are a correlation between the number of ingredients of the total calorie, for example. So to do that, I just have to use the Pearson correlation. I can just do that, Pearson or correlation. I have it. I just have to drag it and to select the value that that I want to compare. So after my correlation, you can see that I have 2 files in hyper, correlation.hyper, and here foodanalysis.hyper. So I will use these files with Tableau Desktop. Of course, I can modify the output with another type of file, like, for example, CSV, Excel file, or I can put it in a database, etc., etc. But for my analysis, I want to use Tableau software. So now I will show you Tableau software. Here. So I use, as I said, I use the 2 hyper file output to create this dashboard. So in this dashboard, I displayed the median of each of the indicators in order to have a summary of my receipts. So we can see, for example, that the median of preparation in minutes is 40 minutes. The number of steps is 8 steps. The number of ingredients is 9, etc., etc. So what is interesting is also to see that the distribution of the note, if I go there in rating, so I can see that the distribution of the notes of the user is very positive with a significant part of maximum notes. So I have a note of 4 on 5 stars. And here I have the average of all of my receipts. So now, if I go on the correlation sheet, I can easily see the result that I calculated with Alteryx Designer. For example, if I go here in calorie, I can see a significant correlation between calories and carbohydrate on lipid level. You can see here, if I go on calories, I have 0.86 in correlation with carbs, and here strong correlation with fat and with sugar. Of course, I assume that it's obvious, but it's always interesting to have this view. But on the other hand, there is very little correlation between the number of steps and the total calories. If I go there, in the number of steps, you can see that there is not really a correlation between them. Even in the fat, maybe just with the number of ingredients, but it's not significant. So all of these analyses, they allow me to have an inventory of my data. So now if I go back to Alteryx, right here, I will use this container, predictive analysis. So, as I said, now as a user who knows the data, a data analyst, I want to go further and try to make a prediction in relation of the history of my data. So I will try to do a citizen data scientist. So here you can see that I have a container in which I will try to predict what recipes my users would like according to their history notation. So for this, I have a file, user train, in which I have here the user ID, and here an indicator on whether he liked or not the previous receipt that I recommended him. So it's a Boolean value, 1 or 0. It's in French, I may, but he liked. So to make it simple, I made a calculation rules before that say the user liked the receipt if the rating is greater than 3 out of 5. So as you have seen in Tableau here, you see that the vast majority of users enjoy the receipts. So normally, I should have a high approval rate. So now, to test my model, I will take a sample that corresponds here to 1% of my total of my user. It's a random sample. And then I will make a join with my receipt with the join tool. And I will use a predictive model that is a logistic regression here. As you can see, if I go on this tab predictive, you can see all of the predictive model that I can use. But I decide to use the logistic regression because, in my opinion, it's the best tool for my needs. So what the logistic regression will form a binary variable, like or not, try to evaluate the relationship between the variables selected to construct a prediction. So here I select my binary variable, so I may, and here I will use predictor variables. So I will use the variable that have a correlation between them with calorie, fat, sugar, but I remove the correlation that are not interesting, like submission year, because there is not correlation with submission year on number of steps. So here I will then run my correlation. And then I will have the result. So I will then use the score tool, already in Alteryx. This tool will allow me to calculate the prediction and output two values, yes or not. And finally, I make a sort to show the user with the highest score. So if I go back in logistic regression, as I said, it's a model that was built by Alteryx. But if I want, I can see in the logistic regression to see the code in the logistic regression. So here I can open it, and you will see that I have error code. See? So of course, the data scientist, if I have a data scientist, it could do the same, but here in Alteryx, I have all of the code that I need. So I just have to use the logistic regression and to put the right variable. This. So after that, I will do a rename with if you like or not, yes or no. And here I have my descending. So for example, for this line, for this user ID, if I recommend him a brown butter and balsamic sauce, it's almost 100% of sure that he will like. So finally, as a citizen data scientist, I can propose this receipt to user and see the result of my prediction. So to be honest, to summarize, a data scientist could easily build this model in Python or R to achieve a similar result. However, knowing this data and knowing how to use pre-developed models allow users to perform this work and let the data scientists work on more complex tasks. So for me, that's the purpose of a citizen data scientist. So now I will go back in my presentation. And just to go back to our company, we are a company that is based in several countries in Europe, and now we have some office in Asia. And we have a partnership with several editors like Tableau Software and Alteryx for my part. So we believe that a data-driven company requires the use of new tools here that can boost the analysis and autonomy of users by allowing them to develop their business. That's why we say innovative analytics to empower business. So who say data-driven necessarily needs data management. So that's why it's for user-based. You have to understand the data to govern them. So that's why here in first we have data management. Know your data, understand your data, govern your data. After, data engineering is to build data platform to collect, store, and access data, like a data warehouse, for example. Here we have advanced analytics. It is the interpretation of data by business users and data scientists. So complex project, decision making. So here it's more my part, advanced analytics. And we have this vertical solution. Vertical solutions are developed on the basis of experience to address specific pain points, but is related to data engineering and advanced analytics. So that's why in the part that concerns us, the advanced analytics, we have the solution about the self-service analytics and the data science. We also have an innovation cell led by Benjamin, our data scientist. So I finished my presentation. Thank you for listening to me. I hope now that the concept of citizen data scientist seems clearer to you. And don't hesitate if you have any question to send me a message. Thank you and have a nice day. Goodbye.